And our first speaker is very well positioned to start off this discussion. Jan Vandenbrouke is trained as a specialist in internal medicine at the University of Leuven in Belgium. In 1979, he obtained a Master of Science in Epidemiology at the Harvard School of Public Health, and in 1981, a PhD at Erasmus University in Rotterdam in the Netherlands. He's professor of clinical epidemiology at Leiden University Medical Center in the Netherlands, and since 1986, he's been there since 1986. And for the past 30 years, he's mainly been involved in the conduct of observational studies. His main interest is the application of epidemiological methods to problems of etiology and pathogenesis that are investigated in academic medical centers. With that, I'd like to welcome Jan Vandenbrouke. Jan, can you hear me okay?
Yeah, I hear you fine.
Great. So I'll now hand over to you. Welcome.
Thank you very much. May I first of all thank the organizers, not just for inviting me for this event, but also for allowing me to give my talk by video conference. I had looked very much forward to attend, but because of personal circumstances, I am prevented. Now, my main background message is on my first slide. And my main message is that scientific insights evolve. They are continuously replaced. There is this wonderful quote by Max Weber, originally in German, of course, but this is a very nice translation. And what he essentially said is that all scientists know that what they have accomplished will be out of fashion, will be forgotten maybe in 10, 20 or 50 years. That is the fate to which science is subjected, and he said it's the very meaning of science. Doing this, every scientist knows that this is what's going to happen. It's the meaning of his work. And my main message is that this also applies to our standard ideas about observational versus randomized studies. And I heard Dave Sackett speaking this morning, saying that maybe in 200 years our views about observational versus randomized studies would be different. So we're in full agreement, and my talk might stop here. I won't, because he did set this time frame of 200 years, which I think is too long, because change is already taking place now, and also because he thought that the solution would come from biological insights, which I think there is more to say about other changes that might influence our views. So the standard view is that RCTs and observational studies are pitted against each other as if there existed some clear-cut difference that has been defined once, that will always be present in each occasion, and that will be forever be true. Now, the challenges to this view are, first of all, this may seem so on the basis of present day or even past theory, but the actual practice is different. There are huge differences in credibility between types of observational research, and there are equally huge differences in credibility between randomized controlled trials. And in addition, we have new theoretical insights that move forward. They move forward and they lead to greater unity and to mutual influences in design and analysis of these two types of study. Now, in practice, there is this great variety in credibility of observational research. Think about genetics. Think about infectious disease transmission. It would be completely foolish to say that genetic research is level 3B to 4 evidence, or that the evidence of transmission of HIV is level 3B or 4 evidence or even less, which it would be if you apply standard rating of evidence. The reason is that a lot of this knowledge in genetics, a lot of the knowledge about HIV transmission is based on, say, rather hastily set up case control studies, even case series that did not make all the fine theoretical points that are necessary. Now, the main reason for the credibility of these findings is that there is little scope for confounding. It's more or less the same reason that was transparent in the talk of Dr. Redelmeier this morning. When there is little scope of confounding, in certain instances, you immediately believe. We all know that observational research other types of observational research are much less credible. Think about nutritional epidemiology of chronic diseases in high-income countries. We know there's rampant confounding by lifestyle, by all kinds of characteristics of people with their diets, and there is a lot of intermixing of effects of, say, the nutrition and the type of foods. Now, for today, I won't talk about all these other types of observational research. I will talk about therapeutics, about intended beneficial effects and unintended adverse effects of treatments, because these are the areas where randomized controlled trials seem to be the king. Now in practice, again, there is this great variety in credibility of randomized trials, not only because of the usual suspects, the quality and design of analysis, which might differ between trials, but there is also this contrast between what I've called the fancy acronym multi-center big pharma sponsored trial, the FAPS trial, which I've invented for this occasion as an acronym, where some new drug is studied by a protocol, by data collection, by analysis, all by writing, all done closely watched by the sponsor. This type of trial is strongly distrusted by doctors, as we learned recently in the New England Journal of Medicine, and we all know that these doctors are right. We don't have to elaborate on this. This is in contrast to the public money trial that is usually set up to solve existing clinical therapeutic problems. Now, the theory would predict that for intended effects, meaning for expected benefits, there should be a huge difference between randomized controlled trials and non-randomized studies. Because in daily practice, treatment is always given according to prognosis. And in observational studies, you use the data from daily practice. And in daily practice, doctors observe, they give treatment according to the prognosis they think the patient has, and doctors are quite good. It's maybe one of the things they're best at in judging prognosis of people. This means that all their therapeutic decisions are going to be hopelessly and quite strongly confounded. That's why randomized trials are needed. This is in contrast to the adverse effects, the unexpected harm, where the theory would predict that there should be little difference between results of randomized trials and non-randomized studies, because in general, not always, but in general, most of the time there is little scope for confounding by indication. Most adverse effects can either not be predicted or are not taken into consideration when prescribing. And this is actually the equivalent of concealment. This is the concealment aspect of randomization, is not knowing, not being able to predict which patient is going to have an adverse effect, or not taking it into consideration. Now, that is what theory would say. But for intended effects, the empirical findings are not in line with theory. We know that confounding by indication should be universal, should be strong when comparing observational studies with randomized trials, but over the past 3-4 decades, there have been several efforts, quite often by what I would call RCT aficionados, to show the differences between observational studies and randomized trials, and by and large, no real difference were found, except maybe for some slightly larger heterogeneity. Schreier, American Journal of Epidemiology, has given an overview of the findings. I have myself, a few years later, rehashed this, and this is the overall verdict. What's quite funny is that, at least it's funny to me, that in such data interpretations, in such comparisons, you see quite some what I would call data dredging. There is one abstract, this is just one example, there are other examples. In an abstract in JAMA 2001, John Ioannidis wrote that non-randomized studies tended to show larger treatment effects with an impressive p-value. Now this paper is completely open and transparent. We have shown all the data, and this is figure 2 from that paper with all the data. Now, if you were to draw a 45-degree line of identity through these data, you observe that all the data points are actually rather close. And what are the data points? The data points are, each data point is a cluster of odds ratio of randomized controlled trials. And on the x-axis and on the y-axis is a cluster of non-randomized studies on exactly the same topic. Now, except for two outliers, one on top and one at the bottom, there is a very nice correlation, and actually the correlation coefficient is 0.83 inclusive of the outliers. Now, how was the statement, the abstract, arrived at? It was arrived at by omitting 6 studies where it was not possible to know which study design produced most favorable results, say a few of these studies in the middle, and by omitting 3 review studies where the RCTs had shown larger treatment effects, which were later doubted in subsequent studies. But the original systematic review had shown this larger effect. So there's quite some judgment involved in making these comparisons. And with the same data, one might equally say that except for these 2 outliers, things are pretty much in line. So what about the alleged superiority of randomized trials for intended effects? I generally tend to believe it, in the sense that it's a nice theoretical notion. It should be there, even if it's not empirically shown to be present. Yet I know there are these clear and convincing anecdotes, and we have heard some this morning by Dave Sackett, and there are many others, where there was great hopes for new treatments which did not pan out in randomized controlled trial. So the ultimate judgment on randomized trials is superior when possible, often not possible for adverse effects, and if done for the right reasons by the right people, meaning people whom I trust. And I've already given you my prejudices, so you know which people I trust. And so ultimately, it's a mix of, say, scientific, theoretical insight, and some sociological criteria. Let's now turn to adverse effects. For the adverse effects, the empirical findings are in line with theory. Why? Because there is no difference between observational research and randomized controlled trials in instances where the randomized trials are possible. Most of the time they're not possible for, say, adverse effects that take a very long time or are very rare. But in the instance where they are possible, Ioannidis first, a number of years ago, did a systematic review, found by and large identity, and there is a more recent and more comprehensive review by Golder et al. PLOS Medicine 2011. This, what I show here on the slide, is the main graph. And again, here each data point, it's a kind of funnel plot, and each data point here is a ratio of 2 clusters of odds ratios, 1 cluster of odds ratio from randomized trials, 1 from observational studies on the same adverse effects. At this time, it's adverse effects. And you see how nicely this funnels, except again for 2 outliers, beyond chance. And the main conclusion by Golder et al. That it's a matter of precision. When the studies are large enough, randomized trials and observational research, they are perfectly in line. Some of these outliers beyond chance can of course be explained, for example, because in the RCTs some risky patients are not enrolled, so you don't see any of the adverse effects that you do see in real practice where other types of people get the treatment. So again, there is this question of superiority of observational studies for adverse effects. And for adverse effects, it's often said, and I've said it before, they have the advantage of longer follow-up, real-life situations versus selected enrollment in trials. Again, to be fair, the only real comparison that we have is not for longer follow-up, not for very rare conditions, where we have a comparison with randomized controlled trials. There is alignment. Whether or not they're better for longer follow-up, whether or not they represent more real-life situations, remains anecdotal. even if it may explain some of the outliers in these comparisons. So to me, the ultimate judgment about observational research is that it's at least equally good, or maybe even better. If you leave out the bad apples, like nutrition research, if you focus on fields such as adverse effects, genetics, infectious disease transmissions. And again, if it is performed by people whom I know to know their business. I'm not the only one saying so. There is a wonderful quote by Schultz and Grimes in Lancet 2002, where they say, a notable friend of ours, David Sackett, told us that he would trust only 6 people in the world to do a proper case control study. This was in a paper about the difficulties of case control studies. I think 6 is a nice number. I think that's about the number of people that I would trust to set up a randomized control trial in close collaboration with the pharmaceutical industry. So I think we're even there, and maybe all of these people are at this moment in the room I'm talking to. So both designs are evolving, and that's the second point that I want to make, except the practice and the theory. Both designs are evolving. RCTs get better all the time. Conduct of trials improves. Observational research gets better. There is, in this 21st century, a new wave of theory. It's called causal inference, that leads to, that in my view, leads to a new kind of thinking hygiene, and is very popular among epidemiologists, very popular in schools of public health at this moment. It has a few main principles, like be certain that your exposures emulate well-defined interventions, which is, if we think about drug exposures, rather easy to do, although there's some, well, I will discuss one complication in a moment. Enroll first user cohorts, also for causality. I mean, this principle was already mentioned by, I think, by Lau Parsis in JAMA in the 1980s, that you should have cohorts with people with incipient disease. Now, also for causal reasoning, people are saying you have to enroll first users. There should be close attention to what is called positivity exchangeability. I'm not going to explain that. That's in the references and the books about these topics. We also have better statistical methods. The newer statistical methods turn away from models with their unlikely probabilistic assumptions, but they're based on the idea that the same population observed twice, once exposed and once non-exposed. And to arrive at that analysis, they actually use modern-day variants of, well, 19th century standardization of rates. They standardize rates once to the exposed population and once to the unexposed population to be able to compare the same population under two circumstances. It has, of course, fancier names these days, because and it allows much more flexibility than standardization. It's called marginal structural models, inverse probability weighing, G-estimation, and similar things. So the design and the analysis of observational studies are starting to influence each other already now. They are getting interchangeable. The newer insights in causal inference in the 21st century lead to similar type of thinking about design and analysis. And the reason is, as one of the leading people in this new field, Jamie Robbins from Harvard, is purported to have said once that all randomized trials are actually observational studies a split second after randomization. Because after randomization, you're observing and you have all the problems of observational studies that we all know and that mar randomized control trials in exactly the same way, like adherence, loss to follow-up, etc. And the study designs learn from each other's strength. And there are examples where things have been solved that previously were not solved. Think about the HRT controversy, the hormone replacement treatment controversy that was talked about by Dr. Yusuf this morning. It's the ultimate anecdote about how bad observational studies are. It has been solved. It has been solved by a randomized control type analysis by using this principle of first uses on the observational data. Because the observational data had all analyzed people starting with current users. Now, if you start with current users of HRT, most people who use already past the first, say, 2 years, the time window where the harm is largest. Miguel Hernan and others said we should start from exposure onwards, and they reanalyzed the data of the observational data. They used exactly the same data as in the nurses' health study, for example, used exactly the same data, and they found that if they looked from observation onwards, they found exactly the same thing as the randomized trial, meaning an initial risk. That was not seen in the observational studies because the first years had been truncated as they had only analyzed current users. If you want to know the argument in short, I've added a reference to this slide, which is not in the slides that you may have. I wrote a short commentary about how, when, and why this controversy was solved, and both the observational studies and the randomized trials are in line in Lancet 2009. And the beautiful thing is that somehow the randomized trials had it right on the cardiovascular aspect, and the observational data had to be analyzed differently, while the observational data were maybe more right about the breast cancer once the RCTs were analyzed like the observational data. So it's a very useful lesson about the unity of these type of data and how you can, with say in-depth thinking, do the analysis and use the analysis type of the one for the other and come to similar conclusions. Other things that have happened is that these new methods allow also to solve some selection bias by selective dropout or follow-up. They have also been used over the past few years only in randomized control trials to solve problems of non-adherence. Also in the HRT field. In the HRT field, the analysis, these techniques have been used to reanalyze the randomized trials to see what would have happened if people would have stayed on HRT. Well, like a lot of you would suspect, things got only worse. Now, these are some of the things that have been solved by applying observational ideas to randomized trials and vice versa. Some of these new ideas are unsettling to, say, classic observationalists like myself. They question the value of incidence density studies, of case control studies in dynamic populations. This was my bread and butter over the past 20 years. And they frown upon it not for the usual problems with case control studies, but because these studies often forget that they don't start from first exposure onwards, since they are in dynamic populations. Other new insights are unsettling to trialists, like the questioning of some deeply entrenched notions about intention to treat, like in the analysis about HRT, suppose people would have gone on using. Still, however unsettling to both sides, I think we should welcome the fact that there are new insights and new discussions taking place. In conclusion, science, and also medical science, is a system of beliefs. It's set up by humans, and it's society of humans who say that they agree that they will try to adhere to some idealized values like organized criticism, open discussion, universalism, sharing of ideas, sharing of data, and things like that, described by Mert in 1973. Mind that this is a sociological phenomenon. It's not guaranteed to exist forever. Whatever science shortcomings, and however tortuous the ways of science can be, and they can be tortuous. The great thing about science is that it leads to this continuous replacement of present-day insights by new insights. And therefore, the US philosopher Charles Peirce wrote already in 1877 that therefore it's a better system than dogma or authority. And again, as I said in the beginning, For the very same reasons, the strengths and weaknesses of RCTs versus observational studies are not cast in stone forever, neither in practice nor in theory. They're fluctuating, they're hazy, they often remain a matter of ad hoc judgment. And we should be prepared, and to be gladly prepared, to see our insights evolve in the future, maybe as a result of this conference. Thank you very much for your attention.